Director of Local Branch, and today it's my pleasure to have you here, because I see pretty much like 2/3 of audience who have never been on our events before. We are usually conducting open events either in the second half of the day after working hours, when we call this Speaker's Corner, which are very brief, but our format today couldn't fit into this. So for these purposes we have Ciklum Saturdays, and this is one of those. Pretty much Ciklum Saturday is the chance to dive into some specific topic or meet some specific people. And today it's our chance to talk to very cool people coming from our new client, Addison Global. And let me introduce our speakers. So the first one is the chief architect of Addison Global, Jose Luis. He will open the day today, and he also has some interesting trick and surprise for you. Then João, naturally. João, head of web development, he will be the second one speaking, and the very last, but not least, it's like, you know, a carrot on the cake. So that's Daniel Ortiz, VP of Engineering, who will also surprise you a lot about metrics and all this deep dive.
I hope so.
Yeah. So, pretty much enjoy the day. Remember that if you have a question, ask. These guys are here today specifically for this purpose, to tell you something interesting, but also to have a very active dialogue with you. Organizationally wise, most of you already got acquainted with our floor plan, right? Where to find what. There is a big fridge standing there with fresh drinks, in case you need refreshment, and I think you will need it. And then we will have lunch, which is not only typical lunch, because we will use this time also for networking and talking, and that's your chance to ask also technical questions, the ones which you didn't address during the sessions. Okay? More or less clear. People who can help you with navigating: Jose, Alex, Irina, beautiful lady whom you've seen downstairs, Begonia, myself. And also some people from Ciklum here, so if you get lost, try to ask. In most cases, you will find helper very close. Okay? Good. So, your stage.
Thank you. So, as Svetlana was saying, thank you so much everybody for coming. We understand that it's Saturdays in the morning. It's kind of difficult because maybe you went partying yesterday or something, so thank you so much for the effort. Hope you enjoyed the session. Thank you so much also Ciklum for organizing the event, hosting and everything, and of course Addison Global for giving us the opportunity to come here to speak to you directly, and also for these fancy t-shirts that we are gonna give to you after the events and while lunch probably. So let's warm up a little bit because it's quite early in the morning. Let's start with a bombshell. There is CRUD is there. I don't know how much time you have been working with this kind of systems. These databases like create, retrieve, update, and delete. That's something that we have to take away from our minds. But we're gonna see whether it's really dead for good or not. We're gonna go into a little bit into the discussion. During this talk, I'm gonna present to you a couple of other techniques that we can use in order to handle the state at scale, which is essentially what we aim. We do a lot of things with big data these days. All the companies are crazy with big data. It's been a main topic for many people, and it's for a good reason. About myself, as Svetlana was just presented me, but anyway, has already the slide, Chief Architect at Addison Global. A couple of ways you can contact me straight. I don't use much Twitter, but anyway, I'll probably receive an email or something, so I will probably come back to you. So to start with, I always try to put a little bit of the picture where we came from, where we're going to. And essentially we start with a quite simple applications a few years ago. Our organization required us to develop something. We put that into an application server. perfect. We have a database, a small one, a MySQL or something, whatever thing, LevelDB or something like that. We start working with that. Perfect, it suits our need. But eventually we start to have more and more clients all the time, and also the business starts to require us to put more requirements into our application server. What happens is that application server starts to grow, that database starts to grow, and it gets to a point that we are, possibly the business is doing so great that it is able to go globally and attend so many clients at the same time that all of this server serving our application with more and more features just put all together into there without any governance. The database becomes so big that essentially this model does not scale anymore. We have built a huge monolith, and now it's time essentially to break that monolith. And that's why you have seen probably during this last, let's say, couple of years, lots of presentations around microservices, which essentially is a way to design your system in a way that you can divide your whole business logic into more individual business units. Those microservices are going to be loosely coupled, intended to be designed for failure. That doesn't mean that they are intended to fail. That means that in case they fail, they can't recover. And other things that are quite good about microservices is that usually can be deployed independently. They can work independently, but at the same time, they come in systems. So they have to talk to each other in order to go for the greater good. So all of that favors all the things that we have listed here, and probably more than that. Modularity and encapsulations, workload partitioning, sharding the load across clusters, horizontal scalability is a must of microservices, isolation of your failure, that's a design principle that you need to embrace if you want to take this right. And automated governance is something that you definitely will need, because when this thing scales, you end up having like lots and lots of microservices, so you have to put like a good governance around it. But at the same time, usually those microservices, everybody says, okay, make this as stateless as possible, and you can probably scale them out quite easily. Okay, fair enough, but there's no such system that is stateless unless you are delegating the problem to someone else. So definitely we are going to have to deal with the problem of scaling out our data. As we were saying in the picture before, we were seeing that we have like relational databases that were really good when we were talking about the small data sets. Standalone in the meaning that back those days you will have just a single node and that's it. Nowadays there are some databases that are still relational, but can have more than one node with different options and capabilities than NoSQL databases. The data was quite a lot normalized, and everything was fit in a single database. Writes, reads, kind of everything. The first time when we were seeing having like other databases was for analytic purposes, but still we're using this system. These kind of systems. Soon enough, we saw that it didn't scale and took a lot of time in order to elaborate everything around data. Transactions was a big thing about these databases, and it's definitely something that we will lack on the NoSQL databases. All those systems were based on those two principles, CRUD and ASIS, which is create, retrieve, update, delete, plus the transactions that were meant to be atomic, consistent, isolated, and durable. On the other hand, because our data state started to grow, then these NoSQL databases started to appear. Why was the reason for those databases to appear? Is because we needed to deal with larger data sets. Scalability is a must for these kind of systems. Availability is also quite key, because one of the things is your clients are gonna go to your site, and they don't care if you have an outage or not. They need to see your page up and running all the time, so you need to have this data available. Performance also is quite key, and these days is starting to be more and more key because the perception of the speed is something that the customer is a must for them. Opposite to the principles of relational databases, we see that we don't have the query capabilities that we were having on the relational databases. We lack of these kind of joins in a kind of nice way. So what we usually do is we create an ad hoc view for whatever we need to present to the customer, and that goes into another table in that database or whatever mechanism the database provides. And no transactions, which essentially give us to the word of eventual consistency that we will talk about that later. All these databases are take this CAP into account, CAP theorem, about essentially you cannot achieve consistency, availability, and partition tolerant 100%. You need to compromise one of those in order to achieve more of the other. Okay, so let's start with event sourcing, which is a new way of modeling your systems. And well, new way. It's been already there for a while, but it's new in the sense that more and more people is starting to adopting this technique. It's a little bit about, if you ask yourself how you would model a change traditionally in your data. Usually you start with a given state A. You want to just travel to state B. What you do is you essentially wipe away your previous state and you put a new one on top, like update, essentially. In event sourcing, this is a little bit different. If you want to transition from state A to state B, what you do is you create an event that captures the what has to change what has changed in the system to go from state A. You apply a function and you are then in state B. That's how event sourcing is it. So essentially, what event sourcing forces you to do is to think about the behavior of your system rather than the structure. And this is quite good in order to define the boundaries if we are talking about the domain-driven design, when you need to get your whole domain of your business and split into subdomains in order to be able to tackle it. It also forces you to think of something that is quite difficult for people, but we also need to embrace, and is the terms of time, correlation of events over time, asynchrony, how to deal with asynchronous systems. So, may I ask you a question? Can you imagine that we model the balance of in our bank account, we model the data like in a way that our balance is just a number in a row in a table? Can you imagine that? Do you think is something that is what banks are doing all the day? No, definitely not, because imagine what would be the consequences of just doing a little update on one of those balances in one row, for example. It would be just chaos. So what we do instead of that, to track, which is, for example, the balance of one customer, is we apply event sourcing. So now we don't have just the state anymore. What we have is two things. We have state, which is usually in memory, and also we keep track of all the events that brings you to the actual state. So let's say we start from scratch, we apply first event, we apply then second event, we apply third event, and then at the end of the day we have rebuilt our state. So essentially what you have built is you have built your state in a functional way. So now, for example, your state can be seen like a fold left with an initial state and with function that is from your actual state. With this event you go into this new state, and that new state is going to be fed in the second step of the fold left as the actual state, the new event, and you get to the new state. So essentially that event log is immutable, is a sequence of events that have happened in the past, and you are not entitled to change the past. And that's something that happens in reality. Are you able to change the past? So probably not. So in that particular sense, that technique will allow us to, if we have our state in a given moment in time in our application, and that application crashes, we are able to reveal the whole state from the very beginning to now. And we're going to see later on that this technique allows for all the capabilities. Sorry for the colors there. There are different reasons why you might want to use event sourcing, but also keep in mind that every time you use new techniques, there are some trade-offs you need to take into account. Not all the time this is a good technique for everything. You should have a look and think what might be these techniques useful for in your domain and apply it accordingly. Okay, so we start with a audit trail. So just by nature, every single change is going to be captured in a log. So by default, you have your source of truth with all the audit of all the changes that have happened since the beginning to the moment that you are in your state. So if you have to design a system that have like a lot of needs for auditing, this is pretty good. If you think about the example of the bank, this is awesome, because every time every single transaction is going to be appended, and at the end of the day you have your state, which is your balance. And that's what your balance is in your bank. It's just the sum of all the different transactions that have been happening to your wallet, so to say. And if you think of it, you might have something in production, some system working in production. You are creating the events, appending to the event log, applying them to the state, but eventually that crashes. What happens then? You have the ability to copy all those events, take that event log into a testing environment, start to replay all of them one by one. You can put like breaking points or whatever you have. You can inspect how the state is evolving, and it's going to be quite easy for you to find out what is going wrong in that system. Another thing that this event sourcing allows you is to do time traveling. Time traveling in this particular way. You can get to any point in time, grab your entire event log, and just say, get to a subset of it and apply the folder function that I was telling you before. That will give you to the state that you have in one moment in time. If you take more of those events, it will take you to another moment in time. So you have that capacity of do time traveling in that particular sense. And if you think of this, a good example of this could be a version control system. For example, you have Git, and you can go any point in time to another commit that you were doing before, and that allows you also to compare different versions and stuff like that. So this is a technique that has been already there for a time, but is for us to start embracing. Do you feel now a little bit with it like this guy? Will you be able to go back in time and everything with this? Let's see if we can make it happen. Another good thing about event sourcing is the support for distribution. This is not like entirely within the event sourcing, but it's something that you can build upon event sourcing. And it's the fact that, for example, when you apply a new event to your state, you're going to mutate the state in memory, and after that you're going to send a message to a potential broker, and that is going to be picked up by one or more microservices that can easily react to that event. So for example, if a system is let's say that you have a reward system that every time a customer deposits more than £1,000, you are giving them like 10% extra. So the fact of depositing will happen in this, let's imagine this is within a microservice. The state of that particular customer will change. Just imagine is the wallet, and the wallet publishes the fact that that customer has deposited £1,000. That is sent to the message broker, and because of these two microservices, I'm interested on that, are going to consume that event from the queue, this one is gonna, for example, imagine insert this one, is gonna have a look at what the event is about, and because it satisfies the rule of it's a deposit and it's over £1,000, he can react to that and do another thing. And this is really powerful to satisfy reactive principles and build other systems upon. Nonetheless, if you have good nicks for in-memory processing, this is a good fit. And I think we have a little bit already talked about this on the other slides. But essentially, the only operations that you do into disk is the fact that you need to persist the events. After that, all the processing can be done in memory, and that is blazing fast. It's really, really fast. And if you think about how much can fit in memory these days, you can think that this model is kind of suitable for that. I'm not saying with this that everything has to be kept in memory all the time forever, but whatever you need to process in a given moment is really suitable to do it. And in case you need to blow up your state at any point in time, be conscious that you have your event log in disk, so you can recover the actual state from that quite easily. It might take some time, but you will have it there. We're going to see later how we can minimize that time, for example. The other thing that event sourcing enables you is to have like alternative histories. And this can come in two different ways. So imagine you have initially your event log, you're applying a function that takes you to one state. It's not difficult to change that function into another thing, and that will take you to another different state. And then potentially you can compare those. You can argue with me whether applying a different function might take you to something that is not properly consistent, but still I'm talking about a testing, comparing, and then you can check, so you can predict how would you have been if you have applied this function instead of the other one, or how you would be in the future if you apply this function instead of the other one. And another possibility is take all that event log into a different environment and do something that is not properly allowed, but so to say, but you can play with it and compare as well, which is, imagine that you have a failure or a buggy event there, or an event that is missing. The consequence of that particular event missing could be, I don't know, but imagine that you have to, you are rolling out your pay slips for all your employees, and you're missing just one, the payroll for one particular employee. That might lead to that employee having to pay different taxes because it goes into another tax code and something like that, which is something really difficult to calculate by hand. So what you can do is, okay, this is what has happened. This is the real state of my system. I'm gonna take that into another environment. I'm gonna blow up that state. I'm gonna make room in order to put the event that I think I should have put, and then essentially you're gonna replay that. And now you have your state after applying the function when with that event that was missing in there, and you can compare how was that before and how is now, and you can get to put that back into production potentially if you want, taking carefully for. Nonetheless, there are of course different trade-offs, and those trade-offs usually are in the shape of complexity. So this is a different approach. People is not really into this approach yet, or not much into this approach yet. So it takes some time to digest it and put it in practice. Another one is when you apply this to distributed systems that are really, really big, how to come up with unique universal identifiers, because those identifiers for different events should be different. And the fact is that in distributed systems, you probably are going to have, for one particular microservice, you are going to have that in cluster. you cannot, like for example, make sure that you have, if generating an ID is a function on time, you are not really sure that that your time is in synchrony with the other box, and so on and so forth. So probably you need to think of a way to come up with a predictable, more or less predictable and non-colliding identifier. Another thing is the events usually change over time a little bit. So you have some requirements, and 3 months later in time, those requirements might change. So you need to have like, or put a strategy in place in order to version those events. Sometimes what you need to do is to come up with yet new events in order for this thing to work properly. But I mean, it's something that you have to take into account definitely. The next one is snapshots. And I think I mentioned something to you before, and is you can tell me, okay, Jose, this is great, but all the time I have to apply the function to the whole event log. Given my event log is so huge, it takes a lot of time and I cannot afford it. So what do? What you can do is, instead of just having that event log, you can also save snapshots over time. So let's say you have an event log for 1 year. So at 6 months in time, you take a snapshot on how is the state in that particular moment. And when you need to bring back the state, you start from that initial state and then reapply all the events, and that will give you to the same final state. And now is the next question. Events usually change in time, not so often, but the state, the representation of the state of a given entity, that's even more subject to change over time. So be careful, because all those snapshots that you're going to create might also need to be versioned, and that's a little bit more painful than versioning events. And what I mentioned before about asynchrony is synchronous processing by nature is quite difficult for human beings. So in a nutshell, in event sourcing, you're not able to change or delete the past, and you can only read and append new facts into it. And to put an example of how real this is imagine all the Brexit situation, for example. Imagine what would have happened what will happen later on if does not get implemented. Is it possible for you to go to the past and remove all those events? Of course not. All the things that have taken us to the actual state have already happened. You are not entitled, and you are not able to change that, unless you are the guy before on the animated GIF. So essentially, what you can do is to append yet new events in order to change your perception of the state over time. So this leads us to essentially say, CRUD is dead, no update, no delete, please. Transactions is something that is out of the equation in the sense that it's really difficult to manage in a distributed system. So instead of having transactions or distributed transactions, what we need to apply are sagas. I haven't prepared anything really for around sagas, but I can give you like a quick introduction. Imagine that Brexit was a transaction. What will happen, hopefully 1 year or 2 years in time from now, when they say, okay, Brexit is delivered or Brexit is not delivered, Brexit is committed or Brexit is brought back. Up to that time, you probably won't be able to do anything with that, because this is within a transaction, has to be consistent, atomic, durable, so I might not be able to do anything, so the UK could be collapsed. So that doesn't happen in the reality. So what will happen is, at this moment in time, if they decide to commit, so to say, they're gonna say Brexit is delivered, and that's your event. And if Brexit is not implemented, what you're gonna have is an event saying we don't we didn't deliver Brexit, and more events will happen and will model the state in that particular situation. Okay, I have prepared a little demo. It's using Akka for event sourcing. It's quite basic. What I want to show you is essentially the building blocks. So it's not production code at all, but anyway, I can show you just a little bit how this event sourcing could look like. How many of you have used Akka, Scala, or something similar? Well, we have just one attendee. But anyway, hope you more or less get to see get to take the whole point of it. Well, Akka is a framework for the JVM that implements the model, and it's a really good way of modeling the distributed systems that have to deal with concurrency, parallel programming, and also distributed load. I'm gonna go quite fast here because there's not much people with experience in this, so it might be quite cryptic, the code. But initially, I'm setting up everything. What I'm doing here is I am creating two different actors. Let's think of an actor like a person that is going to be responsible for something. And the only way to communicate with this actor is just message passing. So what I'm going to do is I'm going to create a writer, which is going to be, I have there also the reader, but it's for later on. I want to come back to this demo after a couple of the slides. That guy is going to be event sourced. Okay, so all the things that are going to happen in this actor are going to, that guy is going to create an event and persist it in the event log. And in order for me to interact with that actor, what I'm setting up here is using Akka HTTP in order to set up a pretty bad REST API, but suits for the purpose. I'm going to show you how it works now. The writer actor, what this guy is going to do is, let's skip the recover side for a moment. So when we deal with event sourced actors in Akka, what we do first is we try to recover the state from the events log, and then is when we start to handle new commands.
Excuse me. Can you make the text a little bigger?
So when we receive a command, which is here, what I'm doing is just I'm just putting some random number with an event that holds a random number and the counter of that event. We should validate the command. So usually it's something that you need to check against your actual state to prevent commands to happen if the state is not suitable for that command. So for example, my balance at the moment is 0, and someone asked me to give them £10. I cannot give you £10 because I'm 0 credit. If I am 100 euros credit and someone asks me for £10, I can give you back £10, and I will gonna say I have given out £10. That's gonna be the event. I keep track of the actor that is sending the request in order to reply later. I generate the event, which is just generate one event. As I said before, I'm not taking nothing into account about the state or anything. This is pretty basic, just for the sample. I'm just holding the sequence number all the time. In Akka keeps track which is the sequence number of your event, which initially is going to be 0, and then I just generate a random number. And after that, I'm going to persist that event into the event log. And when it is persisted, I'm just logging in the console, and I will calculate a new state based upon that particular event. My state, because I've just modeled like that, is gonna be, I don't remember what I said. Okay, it's gonna be the sum of all the random numbers generated by all the events. And finally, I'm gonna reply. This is just to reply back to the HTTP side. This is other command that I can handle. It's actually a request. This is just for testing purposes because I shouldn't be at this moment requesting the state of this actor, but just for you to have a look at it, it's worth having there. Okay, so now, hey João, you remember where can you zoom a little bit or change the? It's gonna
just zoom.
What is the preference?
You can do Command plus, I guess.
Okay. Okay, I have the server running, so what I'm gonna do here is gonna generate one event. If you see there, I have persisted this event already, and this gives me back, which is the counter of the event. That is how the code is done. I'm gonna create another event, I'm gonna create another one, and at the end I'm gonna do this thing, which is not really good, but I'm gonna get the state of that event at that particular moment in time. Correct? If you have a look here, I have persisted just those events. I have created my state upon that. What happens now? I'm gonna blow up the application, so nothing is in memory, and I'm gonna run it again. And you're gonna see here that my entity has been recovered by replaying all the events in the event log. Entity recovered, this is my actual state, and if I take it again, there you are. It's gonna do one thing. I told you that you could have different, you could apply different functions, so you have the events. So what we are going to do is just to simulate how would be the state if our function to calculate the state was different. So in order to do that, I'm gonna say this is gonna be double what the random number is, and that's what I'm gonna use for calculating the new state. I'm gonna rerun the app. Hopefully it does not blow up. Gonna replay the events, but right now you see your state is different. So you are able to see how my state would be if I were applying a different function to this event log. I'm gonna just leave it as it was. Cool. So back to the presentation. Next technique that I'm gonna introduce is a CQRS, command query responsibility segregation. Essentially, this usually comes along with event sourcing, but not all the time. So, I mean, they can coexist, not being applied together, but they naturally come kind of together. Everything around a CQRS is about handling the command or the write path side differently than the read path side or the query side. Just to put as an example, we're gonna place an order, which is a command that's gonna be handled by the command manager that will have its own state, right? That is gonna this entity is event sourced, so we create event, we put into the events log. After that, we apply to our own state, and what we do later is we take those events from the event store into projector manager. That's something that is not really needed, but is just to spend a little bit because that projector manager can potentially do broadcast that event to other systems via message broker, can do like an update on a database in order to query the data in a different way, things like that. So after that, when we are requesting, don't know if it's gonna see, there's a lens there which essentially represents and querying the database that has been changed upon the event. And I have, if you see a different view or a different state than what I have on the right side, and then I can reply. This is one of the things that you can have with CQRS, is that, for example, I can query the data in a different way that I write it, but also allows you to decouple write from read and tune accordingly. So if you are heavy on writes, you can tune the writes, and you will be able to still serve quite nicely the reads and that kind of and the other way around. Another example is the diagram that I'm showing you and reflecting what I told you before. You might not need that CRUD injection manager. You might have some part of your application reading from the events log in order to fulfill a different view that you are going to serve to one particular client. For another client, you have another view that is more elaborated and needs to go to, for example, another type of database to elaborate the data a little bit more and serve that state from there. So after seeing this picture, you have to ask yourself about consistency when you are applying CQRS, and you will be quite easily understand that you will not be able to handle the strong consistency if you apply CQRS. You need to embrace eventual consistency, which is not the fanciest things in the world. It works pretty nice, but it's like necessary evil, so to say. You need to get used to it. The reality is not fiction, and as you see all the time, for example, you have in your account balance, there's a transaction coming in. That transaction might go into your account, but you might not be able to see it yet. So your view is not consistent with the right state, but eventually it's going to be consistent. The other part of the demo, which you can imagine, is around this CQRS. I'm going to go back to the reader side just to show you a little bit. There's a reader actor that I created here, and what I do is for the read path, I'm going to query that straight. And the reader actor, what it does is just one thing. It's taking advantage of one functionality that Akka provides, which is a persistence query. It's using a Akka streams, and essentially what it's doing is going to the events log and querying the whole events log. A subset of the event logs is up to you. Here, for the sake of this event, I'm just going to query the event log, applying a function, and just to show you that you can have like different representation of the same entity by applying this pattern. I have two requests. One is to check which is the maximum number, random number generated out of the events, and the other one is just a counter of all the events that has been created for changing the state of that entity. So if I go down here, I'm going to restart the application. Hopefully I will be able to replay and get back to my old state. Essentially what I'm going to do now is use those before to say the maximum random number generated in those events is 74. If you have a look, that's correct. And then the number of events that are generated at 5, you can count them quite easily, is correct. It's quite easy to change the function in order to give you another view. Of course, this is just an example. Things will get more and more complicated, as you can imagine. But at least I wanted to show you which are the basic building blocks in this presentation. So takeaways, event sourcing, events log, immutable sequence of events. You can reply them to your state. CQRS, you can have different models for read and write and different paths according to your making it suitable for your requirements. Just to remind you, there's no silver bullet for everything. So there are use cases where these techniques are really worth it. CQRS in particular is difficult to take it correctly, but it's going to be useful in some scenarios. Might be other scenarios that is not useful, but use them wisely and probably you can get the maximum out of it. Thank you very much, and I'm ready for any questions that you might have. Go ahead.
See, when the event contains lots of data, say a file upload of a video, what's a strategy for persisting the event?
Yeah, so probably in that particular sense, what you are going to have is a separate store for the video, and your event is going to be my video with this ID has been uploaded. And that would be, for example, your event. But definitely it's not something that you will embed in your event. The event should be quite small, and one of the things is enabled in order to be able to reply them quite fast. So I would say in that particular sense, you might have like a separate storage for that thing.
As a mutable store. An immutable store, where you save that version specifically of the...
Well, ideally, yes. Because if you change the video probably and you want to apply, yeah, essentially that, yeah. Otherwise, you will be quite good in one side of the equation, but pretty bad on the other side of the equation. So better to be aligned in that particular sense. But yeah, of course. Any other?
So the question about, you were talking about the time,
Yep.
which takes after event is like happened and the state updated, right? So
Yep.
it may take some time. So in your system, what is the actual average? So about which time we're talking about, like seconds, minutes, or?
In terms of replying the events.
You know, to update the state.
For it to make up the system.
Well, like,
you mean
one of the examples-
CQRS, you mean?
Yeah.
How much time it takes for the system to become consistent? Of
Yes,
the read
for
and
about the
write?
consistency.
It's really tricky questions, and I will tell you why. You're not sure how much it will take you in order to imagine that for the read side you need to do like a expensive operation in order to aggregate data and stuff like that. That will take time. So at least it will take you that time. Moreover, if while you are modeling that on the right side there's a new event coming, that thing is not going to be consistent by the time it finishes. It's going to be consistent afterwards. So probably if you have such a use case, what you are going to build is something that probably batches the different changes in order to, if the operation is really expensive, you might need to batch the changes in order to not calculate that so often.
In the example that you provided, it's when some transaction happens, so the balance is updated. So for a user, for example, if his system is quite high load, right? So what's we're talking about minutes or hours?
It depends on what do you do with the app. I cannot tell you. Usually the use case is we're talking about less than seconds. But if you have a use case that is so huge that, for example, one event triggers the computation of the whole a whole analytic thing that might take up to 20 minutes, you are 20 minutes outdated from that. But usually this should be quite fast. We are talking about having like reactive microservices. Everything should be message driven, responsive, not blocking. So usually are like in general terms are small operations, and the time that you are out of sync is way less than seconds. Depending of course on the network and all the things, everything can happen. So that's why also you need to design your systems in a way that are ready for failures in order to recover. It's not an easy question to answer because it depends on many things. If you know what I mean.
Sure. Yeah. Thank you.
Just any other questions? Thank you so much.
Shall we get started? Yeah, so once again, thanks all for coming, and especially thanks, Rose. I think your talk is going to help a lot in a few slides. So, yeah, my name is João Ribeiro. I'm the head of web development for Addison Global, where we're trying to kind of disrupt the betting industry through some really state-of-the-art customer experience. So basically a mobile-first and mobile-focused company, and this talk is going to be quite focused on that. So essentially we live in a mobile world. So every one of us has mobile phones, and actually 46% of the entire population of the world actually is connected through a mobile phone. As you can see, for comparison, 50% as an actual active desktop device. So the numbers are quite similar, and actually, if you look at the revenue from the biggest companies, mobile is obviously playing a key part. And at the same time, we kind of grew anger about crappy experiences, and really want the best experience anytime, anywhere in our mobile phones. So, yeah. As a side note, actually most of us spend most of our mobile time within an application. Matter of fact, 90% of the time is spent on mobile applications. So they are really convenient and a really good way to provide the best customer experience. Yeah. So despite being a mobile app-centric world, we have the development landscape is quite fragmented. So obviously, building a fully native application, it's very costly. So you need to manage different teams with different skill sets, and basically you duplicate logic, duplicate views, you increase bugs and time to market. So that's not a really great option, at least if you don't have the resources of a huge company. On the other end, between hundreds of different devices and screen sizes and everything, our web applications get really convoluted and complicated. So we end up shipping to the customer and mags of JavaScript and CSS, and a ton of breakpoints, and all of a sudden it just goes chaotic. And lastly, we then tend to kind of wrap these web applications, which are bolted in nature, into kind of hybrid apps. So we start web first, we put some kind of API layer to communicate with the native side, and we call it a day. This is far from ideal. Sorry, this is not working. Yeah, sorry for that. So here we have kind of the same thing, just in a nice graphic. So on the left we have native application development. It provides the best user experience. It provides a familiar experience across whatever device the user is on. They are really costly to implement, and yeah, code reuse is virtually nothing. And on the right, you have the other side of the spectrum, where we kind of are able to support a multitude of devices and screens, but performance is, let's be honest, poor, or can really easily get quite poor, and you don't have the native interactions or APIs. So ideally, hybrid seems to present quite a good balance, but complex apps mean poor performance and poor user experience. So yeah, this is kind of how we feel about the mobile app development landscape at the moment, and it's not a pretty sight. Cool. So let's step back and kind of rethink a bit about our primitives and how we start. So we're just seeing that kind of hybrid apps seem to fit quite nicely, but in my opinion, by starting with web first, we're kind of taking the wrong way. So the goal is to actually give the user the best possible experience in whatever platform he's in, have a low cost of development and maintenance, reuse the logic across platforms and prevent bugs, because like if you write a piece of logic, that should just work no matter where, and it's just the UI that's supposed to change. And we don't want any performance compromise, so best customer experience, minimum code, and the code that's actually required for that specific platform. And on top of all, we want to make our lives interesting and fun and be able to reason about problems in a really good way. So we want to be happy in our jobs. So coming to React Native as kind of the reverse of the problem. So we start really and truly native first, but we still use all the techniques and all the kind of environment that we're used to. So we still use all the web tools, the web kind of tool set and debugging, and it's built on web technologies. It has a great community, and we're able to write code that then can be rendered into multiple platforms like Android, iOS, Windows, VR, and whatnot. So the idea is that you kind of decouple the presentation layer, and you have virtual DOM, and you kind of then that gets rendered and represented into different platforms natively. So you actually run fully native code, and it actually runs on a fully native thread. So this seems more interesting, at least to me. So, come on. It's funny, but not that funny. That's a very good point. So React Native is actually gaining traction. As you can see, as of September of 2016, kind of Android development and iOS development are flattening out, and React Native is growing in popularity. And this is according to the Google Trends. And it's actually developed by Facebook, which and a lot of companies are using it at scale, including Facebook, but not only, so Instagram as well, Airbnb, Skype, Tesla, Walmart, just to name a few. So yeah, React Native seems to be a good fit, but now let's look at how we can actually share the application logic across all the stack. So introducing kind of Redux, and I'm not sure if most of you are familiar with Redux, but for those who aren't, then I think Rose's presentation before just pretty much explains Redux as well. So, and this is actually one of the things that I think it's really good with us, so we kind of speak the same terms in a way. So Redux is a JavaScript library for state management, but it's kind of built upon the principles of event sourcing and CQRS as well. So it provides you a unidirectional data flow, and everything that happens in the system is also an event. So that means that all the traveling, all the debugging, all the ability to pick up snapshots of the state and migrate that to a different device, that's still present. And despite this, Redux is actually it actually mandates that all the actions are synchronous, and that's really fundamental to the way you understand the application state and to the way that it helps you reason about the logic of the application. But we all know that a lot of the things in our applications are actually related to a synchronous action. So going to the network and requesting some data, or even presenting a pop-up to the user once is done a series of actions. So imagine that when the user deposits some money and then goes to a specific page, you want to reward him a promotion. So these kinds of things in the traditional model are actually quite complex. So all of a sudden you're managing the state by yourself and you're listening to multiple events, and when all of these events resolve, then you do something else. So we use Redux Saga for this kind of asynchronous actions and more complex actions, which you'll remember from Jose's talk as well, the mention of sagas. The notion here is slightly different, but you can still think of a transaction kind of model that you're able to complete, although we don't deal that much with rollbacks, at least in traditional kind of application models. So, yeah, so a bit of an architecture overview. So essentially, we have our view provider where React or React Native sit in, and the user is interacting with a given screen. Every interaction is represented in terms of actions or events, which then get passed across to multiple middlewares. So these allow you to kind of intercept all the actions and all the events and kind of do specific things like logging or handling sagas, which then those same events get passed to reducers, and the reducers update the state, therefore updating the view, which gets re-rendered, represented to the user, and it kind of follows the same principle all over again. So essentially it's a state machine, and every time you want to change the state, you need to emit an action, and that's essentially the principle behind it. So yeah, looks a bit better, but we're still missing the web, right? So we went to a lot of trouble to optimize for the native experience, but Chuck Norris is not happy, so let's make it happen. So there's this notion of kind of rethinking the primitives of the web. So essentially what React Native is doing is saying forget about divs and forget about spans and think about, or paragraphs, and think about views and think about text and think about just different set of primitives. And these are just components which you can translate into anything that's really platform specific. So you kind of abstract all the platforms into a common set of primitives. So React Native for web actually allows you to translate your React Native application primitives into web kind of primitives. So you can think that a view is just a div in the background, or some kind of text is just a paragraph in the background as well. The other cool thing is it actually allows you to build expressive and reliable CSS, so it builds on top of the same style sheet that's provided by React Native. And as such, you can actually compile and transpile most of the styles to the web environment effortless. So obviously it's optimized, its browser compatibility is quite good, and you have you still have the interaction with the web APIs, and you have native like touch handling. So this actually allows us for great flexibility, but not all the features are available on the web, right? So we still have a problem. What do we do when you're requesting Touch ID and Touch ID is not available on the web? So for these, we kind of introduced the concept of custom views. So really you need a way of, if you think about a UI that's a tree of components that arbitrarily are put together to compose a bigger view, you kind of need a way of, at any point of this tree, to kind of tap in and provide a custom experience for whatever platform you want. So you can do this by just creating a co-located file where you can put, for instance, a .web.js extension, which then gets replaced by Webpack. So in Webpack, you just say, or whatever other bundling system, we just say, hey, every time you see a web.js file, use that instead of the .js file. So that's essentially what's happening in the background. We're basically just through aliases and compile system just replacing everything and providing specific behavior. But we do it selectively where and when we want. So apart from functionality, we can obviously provide different styles for each platform and basically customize whatever we want while still reusing most of the logic and most of the views. So this is kind of a stack overview of what we're speaking about here. So we have kind of services, or the traditional Redux layer, where you have actions. So every action represents a change to the state, which get done by the reducers. Complex and asynchronous actions are handled by sagas, and we use selectors to basically fully decompose our components. So every time you need some data from another component, you use a selector, which then guarantees that even if the internal data model of a specific component changes, your selectors should still return the same data. So that's kind of the principle behind it. And then you have views, which obviously are implemented in React Native first and get translated to React using React Native for web. And the views and the logic get connected by Redux containers. It's actually Redux React layer. But yeah, so that's kind of the application layer, and we have some tooling to support this. So Webpack, Babel, Storybook, flow type for type checking, and so on. Maybe look at what we're talking about here first in terms of pictures, and then we can look at some code. So essentially, what you're seeing here is a fully native application. I won't restart this because it takes a while to compile to iOS and Android. But essentially, you have a fully native application. The UI is running on a fully native thread. You can create whatever to do, and it shows up in the list. This is the classic to do example. Why is it not working? Love demos. Cool. So let's restart it. Cool. The first thing is actually you see this QR code right here. Now, I don't know if any of you is aware of Expo and the Expo environment, but the good thing, or the really cool thing, is I just have an application on mobile here, and remember, this is fully development experience. So JavaScript is building now, and as soon as that finishes building, I should have a full application running on my mobile. And at the same time, I can launch the iOS simulator. Cool. So the application is running now on my mobile. I can hopefully add a to-do. Yeah, so I've done that, and once it loads here, you can kind of see how it's working across devices. Oh, sorry. Yeah, so if I refresh, basically I got the to-do that I created on my phone, and I can create another one. for some reason there's... Well, anyways, let's move on to Android. Sorry, I had to pause quite a few things. Cool, so I have an Android emulator here, and now I can try to launch the Android application, but while this is running, I have another Webpack server here that I'll just start. And I should be able to load a full web experience without any code change. Sorry, the web environment was supposed to be quick. It's getting as slow as Java and Scala with all the compilations and stuff. But yeah, so we have our list here. Remove this guy, and that's some guy. No worries. Cool, so it's working here. And now let's just prove that we're still able to support Android. Cool, and so an interesting thing is you actually see that the applications have a fully native kind of look and feel. So on the left, you see that we have kind of a material design look and feel, and on the right we have the iOS experience, which is actually shared to the web at the moment, but can easily fix that at a later stage. There's just one last thing that I kind of wanted to demo, which is the debugging experience. So at the moment we have our debugger. So there's basically a web worker that's running on this tab in Chrome, which allows us to fully debug the native environment. So we can perhaps just do a breakpoint before doing the GET request, and as we can see, we can now step through and inspect whatever is happening on the code. So this is, I think, really familiar to all of us as web developers, or at least to the ones that are web developers. So I guess the next thing is what's actually happening on the background, and now we are kind of architecturing and running our applications. Is this big enough, or shall I maybe? Cool. Can anybody see the code? Yeah. So we're kind of following a component first approach for development applications, and the idea is that we want to build the functionality and break down the functionality into very small and units of code that can be reused and reused across any application. Basically, we're able to just drop in the components, and they shouldn't really change. So they should be self-contained, loosely coupled, and all the good things that we've learned so far. So we're actually, to prevent basically huge development times, and the traditional problems with a component-based development is actually you spend a lot of the time doing configuration, you spend a lot of the time creating repos, and basically the onus of creating a new component comes with all of this configuration layer, transpiling, and all sorts of stuff. So we're following a monorepo approach. So that means that all our code lives into the same repo. And this is great not only for the development speed and ergonomics of just creating a component on the fly, but it actually is really helpful for discoverability. So we're actually running a tool, which is a storybook, which is essentially just a list of all your components, accompanied by automatic documentation generation, which we actually use flow type to analyze the types and then automatically generate the documentation for you. And you can have all the examples of all the data scenarios that you want. So if you think about some kind of component which actually depends on data, then the typical scenario is like when you're writing tests, for example, is you actually try to cater for all the data scenarios and you end up mocking requests or doing all sorts of crazy stuff. While here, basically you feed in the data that you want to the component and you let it render. And with this storybook you can define multiple data scenarios and just let those render. So from this kind of a development tool, which you can actually just deliver to any business person, including a business analyst or whatever, and let them start playing with the actual component that's implementing their requirements as soon as it's done. So it's a really interactive process. And the other great thing about this is we can actually take a snapshot or run automated tests on these components and on these different data scenarios. So obviously you don't replace the need for unit tests, but you, without any developer effort, you actually aid the development process quite a lot. So you provide documentation, you provide automatic snapshot testing, and you provide a way to discover and see all the modules and all the components that are part of the stack. And I think that the third biggest point of the monorepo approach, so at the moment you'll see that you have kind of two applications here, but nothing prevents us from, in months' time, just adding another application that will have a slightly different look and feel or have a few screens. Let's say that maybe some light version of the application, so you can still reuse everything and you don't need to get out of your editor or the same repo. So yeah, we can look a bit into our Redux layer and how we are building that logical part of the code. So this is typically a to-dos client, so this is interacting with a backend server. So we have our actions defined on the system. And you'll see a lot of this weird syntax. This is flow type, so static type analysis for JavaScript, in case you're not familiar. But essentially we have pure functions here, right? So you take an input and you generate an output, which is an object and a type of your action. So this describes the event that happened on the system. So in this case, we have a get to dos action, which just says, hey, there's been an event and there's been a request to actually fetch the to-dos. Then we have result action and all sorts of stuff, but you can actually see what I was talking about in the sagas here. So we're basically listening for three types of events here. So we want to be to run a function whenever someone requests to-dos, and in that case we want to call the get to-dos function. So we are constantly listening for the get to-dos action, and we call, once that happens, we call get to-dos, and that's simply going to the network, doing a network request, and then putting either the response on a success action or sending a failure action. And kind of we follow the same principle for adding a to-do or removing, deleting a to-do. And in the end, as I was saying before, basically everything goes through a reducer, where basically you just handle the actions in separate. So if you get an action from the saga that says that the fetch was successful, then we basically return a new state where we have the list as the response. We say that this is no longer loading, and there's been no error. So in a nutshell, that this is really at the core of our logical layer of the code. And you can see here that there's just some static type which will actually help you detecting bugs and problems with your code earlier. And then can just look at a quick example of the view layer. So here we're actually using native base as our kind of UI components library, but that's just an implementation detail. But it's pretty cool, so feel free to check it out on your own. But yeah, here we have kind of a pure React Native component, or React component really. We basically have a container. We're checking if the platform is web and rendering some other thing. This is actually a hack, but yeah, it's just a problem with the versions that I'm using. And if not, we just render the ad, and this is essentially this page header thing, which renders the top bit of the page. And then we have some content. But the point here is, if you're familiar with React, this is really familiar. There's nothing different here apart from rethinking the primitives. As soon as you understand that you don't need to be tied up with a div or a span or a paragraph in a browser context, then you've decoupled yourself from the platform. And I think this is really the main takeaway here is stop thinking about the DOM, start thinking about abstractions. And at that point you should be able to just run your code anywhere, just kind of a translation layer in between. And just to wrap this up, we can maybe look at our main entry point for the application. So nothing really interesting here. We set up some React router, we load some fonts, and we set up the paths. So we have two screens, a home screen and an add to do screen. And exactly the same for the web really. Set up a router, we set up a store for Redux, and that's it really. Yeah, so that's it, I guess. Any questions?
About the primitives blocks on React Native, like equivalent of paragraph, or are they for React Native for web? What do you use? For example, I see button there.
Yeah.
I guess button is native button, React Native button component.
Yeah. So in our case, that's actually interesting. So I didn't want to go into this detail, but we actually have kind of a UI kind of list of packages where we have some primitives, and these basically at the moment, again for demo purpose, we're just exporting the components from native base. But the idea here is that you would kind of build, so the designers would start with some style guide. They would provide to you a list of a set of components, which are the design components, which then will be reused across your entire application. So you would kind of start with the React Native primitives, and you would build upon that the styles and whatever composability. So then you kind of map the design language with your code language, and you have a set of UI components that can be imported by any view, and you can basically just build complexity through that. Does that answer your question?
Yes, yes.
Cool. Any other question?
Yeah. So perhaps this is a bit out of scope to speak of the talk, but for testing purposes, for the reducers are pure functions, so you can just test them as in the test. But for the sagas, because I saw some sagas.js, you're starting from a snapshot or something, or how would you? So there's multiple ways of doing it.
kind of the concept behind sagas is that they're actually declarative. So every time you call a function, you get returned kind of a JSON representation of what that function will call. So you can actually just kind of test by snapshotting as well the different applications of the same thing.
So a white box testing, because you have to know what it's gonna call in the end.
Well, yes. But you kind of need to map your expectation with what has been called. There's other things as well. So Saga testing is actually a bit weird. In my opinion, like if you really want to test it nicely, you should really be triggering the proper actions and see if the system reacted in the way that you're expecting. If that makes sense. So it probably you kind of want to have some UI layer maybe actually to test it more end to end and be fully confident. But I think typically the recommendation is that you can actually kind of call the same functions that you've done on the implementation, and you expect the result to be the same on both ends. About reducers also, there's quite interesting. So as you said, they're pure functions, so input, output, and that's fine. But we can actually do better, because since all our system is type checked, and we've described the types that our functions expect, you can actually do property-based testing. So you can look at the types and generate random values for those types, and then set the input and expect the output. So there's quite interesting stuff that is opened. Anything else?
No, it was a question related to testing.
Cool.
So, okay, it's a question right So finally, do you automate all of this?
Sorry?
What is the strategy of automation of this stuff?
Automation in
Yeah,
terms
it's
of
like is it any other framework, any other approach, or you do something special?
what do you mean?
I mean, so what testing? Okay, testing. What is the
So
strategy
okay.
of testing?
So automation testing.
Automation testing.
Yeah.
Saga testing that you mentioned.
Yeah. So Jorge was asking about Saga testing. Obviously, there's multiple layers of testing, right? So we start by automatic kind of snapshot testing, as I was telling you before. Then you move into unit testing. Probably want to do some functional testing, and all of these you can do kind of within Jest environment. Jest is the tool that we're actually using to test this code. From there, I think it actually gets handed over to a QA kind of team or a QA person, and then follow the normal approach. So kind of test pyramid. So you test components in isolation, and prove that their functionality is correct and meeting the requirements, and then you kind of do as much testing as you can. So again, the ability to inject data, it actually allows us to do incredible simple stuff. So all of a sudden you could stop thinking about mocking huge backends and stuff, and you just mock the data for that specific component if you need to, or you can just inject the data itself. So that kind of means that your end-to-end test layer starts really getting narrow and narrow, and that's really the bottleneck of doing QA at scale, at least. Does that answer your question somehow?
Yeah, partially. So I will probably ask after the.
Okay. So were you talking more of like development tests or?
Yeah. So about the automation tests.
Yeah. But automation.
You partially answered it already. So I understand.
So I guess the other thing is we have code standards and linting, and yeah, and type checking. I think that's quite a good way of testing. But yeah, grab me afterwards and we can speak about it. Anything else? Cool. Thanks so much, man.
Okay, chaps. First, thank you for attending the last talk of the day. I guess that most of you are looking forward to have your lunch. The amazing lunch that the Ciklum have prepared for us, and all the drinks, including myself. So I promise I will try to be as fast as possible, and I will try to finish the presentation in time. Please let me know if I jump on top of the projector and you cannot see anything. I know that I will definitely do it. My name is Ortiz Esquivel. I work in Addison Global as a VP of Engineer. And today what I would like to do is to share with you the lesson that we have learned and the technique that we have put in place while we have been observing and monitoring a distributed system based on Akka. So this is the agenda that we're going to cover today. First, I would like to start talking why I think it's so important to observe our applications. Then we will move in a section where we compare the traditional versus the modern monitoring tools that are available in the market. After that, we'll jump into the peculiarity of an actor system. Finally, we will jump into the monitoring standard we're going to use during all this demo. For the demo, we have developed a very simple HTTP microservice based on Akka and Akka HTTP. This presentation is going to be kind of practical. I want to share with you all the little things that you need to put in place in order to monitor your application. Okay, before I start, this thing is something very interesting. We have two amazing presentations from my colleague João and Jose, and they were talking about amazing applications which scale, which work across different devices, applications which are asynchronous, based on the demand they can scale in, scale out. All these things are fantastic, but I believe that there is something that we usually forget, and it's the fact that the possibility of a failure is always there. So our system can fail. And I think that if we don't pay attention in trying to reduce this risk, it doesn't matter if your application is super fast, it doesn't matter if your application can go up to the sky and you can handle thousands of concurrent connections, because at the end of the day, your application is not safe. But safe means there is not resilience, and resilience for me is not something that you get by default. I believe that an application becomes resilient once that you first start observing your application and then you react based on what you are observing. This can be summarized in the concept of monitoring. Because I'm not good making definition, I use Greg, which is a fantastic guy, and last year he did a perfect definition of monitoring, and he said that monitoring is the action of observing and checking the behavior and output of a system and its component during a period of time. That's a fantastic definition. If any of you have any questions, you can ask Greg and not myself, because I didn't do it. But what I'm going to try to cover is go more a little bit into the detail. Okay, we have a definition which is very standard, but what a monitoring system should be able to do? What are the capabilities that monitoring system should expose to us? I think the first one, monitoring system should be able to measure things. We should be able to collect measurements. But if we collect the measurement, then we need to record them. So the system should be able to record and store them. Of course, if we are not able to do analysis or any kind of visualization on these metrics, what's the point? And after doing the visualization, we of course want an alerting system, something that lets us know if a given measurement arrives and is out of a predefined threshold. We want to be notified. Good. Now that we know what is monitoring and what do we need, let's start talking about the different systems that we have. We have what I call traditional system. In a traditional system, we have a transaction or a request that it can be summarized, or it can be defined as a group of subtasks. Subtasks, as you can see here, usually are executed sequentially. So T1 is the first subtask, and after T1, once T1 finishes, then T2 will start. And there is another thing in common, that most of the time, all these tasks are executed under the same thread. For this traditional system, there are many tools available in the market. And in fact, they are very good. They monitor the system very well. They are able to notify you if a given thread is blocked. They are able to notify you if there is some kind of starvation between all the threads. Because of the nature of this application, you also can see what is the stack trace. It's very easy for a monitoring tool to let you know which is the piece of code that has been executed in a given period of time, because everything flows through the same thread. But again, we want to do cool application, asynchronous, not blocking, message driven. Now, the shape of our system changed a little bit, and we have again one transaction or a request, and we also have a group of subtasks that our transaction have to complete in order to finish. But in this case, the transaction doesn't execute sequentially. They don't need to wait one to the other. They can execute in parallel and in a synchronous way. And there is even more. They are not executed under the same thread. There are several threads that are handling the same request. So this is a bit of challenge. We need to rethink how we can monitor this system. Of course, we can use the traditional monitoring tools, which are available in the market. There are many of them. But if we use them, we're going to monitor our system like a black box. We don't really get the detail of what is going on inside of our application. We want to go in deep and understand, for example, how many messages, how many tasks a given thread or an actor is processing. In order to do that, we need to change our mind and start using different monitoring systems. Right, I'm not going to try to explain what is an actor system, but this is just to refresh our mind how it works. In order to build all this cool application, what we use is the framework which is called Akka. Akka is based in the actor pattern model, and it's very simple. The concept of the actor pattern model is very simple. You have the entity actor, which can be a thread. Please let me use this word. I know it's not a thread, but it's simplified explanation. And this actor doesn't share any data with anyone. The data that belongs to the actor is only accessible by this actor. If an actor wants to communicate with another actor, they have to exchange message. So from a developer point of view, it looks like that we are developing single thread application. We don't have to deal with logs, and we don't have to deal with all the problems that multi-threading application has. For us, it's great. And of course, we also work with immutable data. We have the benefit of immutable data because nothing is shared across the actors. So once that we know what is an actor system, we're going to jump into our monitoring stack. We're going to use a predefined monitoring stack that we can download from the internet. For the purpose of this demo, we have done a very simple application, which is using the framework that I mentioned before, Akka, and you will see in detail how we can monitor it. First, what is the first component of our monitoring stack? It's Camon. It's called Camon. Camon is nothing more than another Java VM monitoring tool, but it fits very well with event-driven application, which is actually what we produce once that we use the framework Akka. Camon allows you to play with metrics and tracing, and essentially Camon is composed by several modules, but there are two types of modules. One type of module which is called collector, which is the one that are in charge of collect all the metrics from your application and make them available. And then we have the exporter, which is the one that read all these metrics that we have collected and flash them into a given backend or a given application. So it's quite simple. We will see later in detail all this concept. I wanted to mention something here, with the collector. There is something interesting about the collector, because maybe you are wondering, right, if I have to collect the metrics, then I will have to change my code, introduce some library or something which will affect my code. So how does it work? So it's very interesting. The collector in Camon use AspectJ. With AspectJ, what the collector does is instrument our bytecode in runtime. That means that we don't need to change anything in our application. Just by passing the agent in runtime, our application will start collecting all the metrics. Second component, StatsD. It's a very light daemon which has been developed using Node.js. And the purpose of StatsD is to listen to all the metrics that has been collected by Camon, aggregate them, and then flash them into a given backend. So StatsD is widely used across many platforms. One of the interesting things that StatsD offers is the capability of communicate with it through UDP or TCP. For this use case, we're going to use UDP. One of the reasons we're going to use it, first, it's very fast, and second, because of the nature of UDP, which is fire and forget. Our application doesn't need to care if StatsD is up and down. It just push all the metrics, and if StatsD is up, it will collect it. Moving into Graphite, this is our third component. This is where we are storing all the metrics collected by Camon, pushing StatsD, and then StatsD finally into Graphite. Graphite, in fact, is more than a storage. Graphite is composed by 3 tools, which is Graphite Web, Carbon, and Whisper. Graphite Web is a web tool that allows us to query all the metrics that we have collected. For this demo, we're not going to use it. We're going to use another one that we will see in a second, which gives us more functionality. Carbon is the metric processing engine, is the one that listens to all the metrics, aggregate it, bash, and then send to Whisper, which is our time series DB. And this is the tool that I mentioned before, Grafana. This is the web tool that we will use during this demo. Grafana is a web tool that allows us to query and to show in a dashboard all the metrics that we have visualized in a dashboard, all the metrics that we have collected. And for me, Grafana is a key component because essentially this component, Grafana, is the one that helps us to understand what is the meaning of all these metrics that we have collected. Thanks to the visualization, we are able to understand what is going on within our application. Something more about Grafana, it supports many backends. In this example, we are using Graphite just for simplicity, but you can plug Elasticsearch or InfluxDB. There are many solutions. Another interesting thing is the community is very active. They have a lot of plugins that you can reuse, and the most important, they have already defined dashboard that you can reuse. The only thing that you need to do is to download the importing, and then the dashboard will automatically visualize all your metrics. And why do I make emphasis on this dashboard? So first, because of the simplicity of the dashboard. The dashboard is just a JSON. And as I said before, as I mentioned before, you can export and import. Therefore, you can reuse and you can share with your team or with your colleagues. So because of setting up a system for monitoring our application is so simple, but because of the reusability of this dashboard, I believe that all these tools will help us to promote a data-driven culture in our team. Let me explain what I mean by this. So usually when we are developing an application, we developers, we put a lot of emphasis on making sure that our application satisfies all the requirements, that our application passes all the tests. But once this is done, what usually happens is we take our application, we forward to the system engineer or to the DevOps team, and then they are the one that make sure the application is monitored properly. They define the dashboard, reusing whatever the dashboard we have as a template, but they are the one that take control of this. And this is what I believe is wrong. The definition of this, sorry, no, sorry. Right. So this is what I believe is wrong. The definition of this dashboard should be something iterative and should take part since the beginning. So maybe you're wondering, yes, another thing that we developers have to do. But don't think that this is another task that we add into our bucket. For me, this dashboard is another debugging tool that should be part of our tool set, because if you start using that debugging tool since the beginning, you have more chance to identify critical errors in an early phase rather than later. So I see the value of defining this and iterate through this dashboard since the beginning. Now we move into how we're going to run this stack. Thanks to the guys from Camon, they already offer a Docker Compose file that we just need to download it, run Docker Compose app, and all this stack is built for us. If you like it, you can do it by yourself, but it takes time, and for this demo, we're going to do that. Something interesting that these guys also provide is two different dashboards. They provide a dashboard for Akka applications and a dashboard where we can visualize the system metrics. What do we need to put in place in our application in order to start taking benefits of Camon? As I mentioned before, Camon uses AspJ to instrument our application and in runtime do this bytecode customization to collect all the metrics. So the easiest way to start using AspJ is to add this SVT plugin into our plugin SVT. After that, we move into the dependencies that we need to add. And the first one, as you can see, is AspJ. Then we have Camon Core, which Camon Core is interesting because it's nothing more than an API that allows you to play with tracing, and segment. It doesn't do any inspection, it doesn't expose any metrics, it's very simple. This is the beauty of Camon, but then you extend it with more modules. So in our case, we are extending it with Camon Akka, Camon Akka HTTP, and then Camon System Metrics to collect the metrics of our application, our VM, and the host system. After defining this dependency, we also have what I mentioned before, the exporter. This first one are the collectors, the one that collect the metric, and these ones are the ones that are going to export all these metrics. So for the purpose of this demo, I would like to export the metrics in the shape of endpings, thanks to the Camon JMS. And I also going to export all this metric to staticity, to the stack that I mentioned before, thanks to Camon staticity. Right, there is something more, because we are using AspJ. As you maybe know, you need to pass the Java agent to our application. There are two options. You can do it manually, just pointing the Java agent to the AspJ Weaver jar file. Or there is another option, which is you can configure your SVT file, just applying these AspJ settings, and then the SVT file will automatically inject it. So we have done the setup, now we move into the configuration. In the configuration, again, there's going to be two sections, one for the collector and one for the exporter. If we start with the collector, the first one that we have is the system metric. This is the module that allows us to collect the metrics of our Java VM and also the metrics of our system, which are the resources that we are using. In order to collect the metrics of our Java VM, we need to enable this GMS this property that you can see there. The second one, GMS enabled. What Camon does is connect through GMS to our VM and then read the default endpoints that Java exposed by default, like garbage collector, CPU utilization, number of threads. In order to profile our system, to know what are the CPU utilization in our system, not inside of our Java VM, what Camon uses is Cigar. Cigar is a native library, a cross-platform native library that lets you know which are the resources used by a given application. There are two options. You can provide the Cigar native library, or you can just enable, as I did it there, and this module by default it will download it for you. Second section is the one specified for Akka. As you can see, there are three main areas: Akka Actor, Akka Dispatcher, and Akka Router, and all of them have something in common, which is this include and exclude. So when we are developing an Akka application, by nature, we can end up creating thousands of actors. Most of the case, we don't want to profile all the actors. There are always specific actors that we want to profile, but not of them, because of course there is a cost implied in the profiling. So thanks to this include and exclude, we can filter, we can define which are the actors that we want to profile or to monitor. Sorry. What we have here, we have just a regular expression which match again the actor names. In this case, in the demo, I'm telling Camon that I want to profile all the actors that I'm going to create under my application, but I want to exclude something related with a string and pool because it will add too much noise. The same applies to the Akka dispatcher. I'm profiling the default dispatcher and also the blocking operation dispatcher. This is one that we will create in our demo application. And for the router, I just want to profile everything. The last part of the configuration is our exporter. How we are going to export these metrics. As you remember, there were two options, GMS and StatsD. In the Sporter, there is something that applies to all of them, which is the subscription section. In the subscription, the Sporter uses the subscription to tell Camon which are the things that they need to subscribe to then export through whatever channel have shown. In this case, for example, in the GMS, we are telling that they want to subscribe to all the histogram, to all the counters, to all the gauge, and then later, Camon will automatically read them and make them available through MPINs. In StatsD, there is a session similar to the one that we are seeing in GMS, but just for simplicity and because I didn't have space, I didn't put it. The necessary information that we need to provide to StatsD is, of course, the location in which port is listening, and also we have the flexibility that we can convert the metrics, we can change the time units of the memory units before sending them into StatsD. There is something more, you can play with the name of the metrics, and also you can also change the frequency when the frequency in which you push these metrics, but for now I'm using the default ones. Right, everything set up. It was a long journey, I know, but now you don't need to worry. This is our application. It's quite simple. The only thing that you need to do is call Camon start to start collecting all the metrics. Once that you call Camon start, Camon will create an actor system for itself, which is completely decoupled from our application actor system. And the Camon module will go through our dependency, will see all the modules that we add, and will automatically start all of them. Of course, once our system terminates, we need to remember to shut down Camon, and that's the only thing that we need to do. The rest of the thing is done through ASP.J and the by instrumentation. So demo time. What we're gonna do here is I'm gonna start the start that we saw before, and this is a Docker compose files which contain all the components that we saw. Then here I'm gonna run my application. And here I'm running JVSonVM in order to consume all the MPINs that our application is exposing. Again, you can use whatever you want. You can use JConsole or Mission Control. I prefer JVSonVM. So here we have our application. If I try to connect it, here we are. We agreed that all the metrics are going to be exposed through MPIN, so we go to the MPIN tabs, and here we have our friend Camon. As a parent MPINs, we have Camon, and then we have all these children, each of them for each of the modules that we mentioned before. We have one for the Akka actor, for the dispatcher, the router, counters, everything. We're going to open, for example, the system metric. This is the one that, if you remember, was profiling our Java VM and our host machine. You can see here are all the MPINs that this module is exposing: CPU utilization, memory, the allocation of direct buffer in our Java VM. You can see also the garbage collector, which are the memory that is free. Everything is here available. But of course, it's nice to have this thing here, but it will be fantastic if we can see in a shiny dashboard. And for this, I forgot where is. We have Camon, we have Grafana listening in port 18. If you remember, we ran the Docker compose previously, and now if we log in, here we have Grafana already running. As I mentioned, the Camon guys provide two predefined dashboards. We're going to start looking to the system metrics, and these are all the metrics that Camon is already collecting from our application. First section is the metrics of the OS, of the host machine, network utilization, if there is any error, CPU process, system memory, context switch, many important information. And then we move into the JVM metrics. As I mentioned before, we saw that in the NBIMs. We have the garbage collection, the heap memory, non-heap memory, anything. Fine. So we already covered this system metric. Now we're gonna continue talking about our application, which is based in Akka. So as I mentioned before, in Akka we have the concept of actors, and an actor has the concept of a mailbox, and if an actor wants to communicate with another actor, it has to be done through a message. So once that we know the definition of an actor, which are the metrics that could be interesting to monitor? So I could think, for example, in the actor throughput, how many messages a given actor is processing, or for example, the actor latency, how long it took an actor to process a given message. Then we have also the mailbox size. So this is interesting to know if we are saturating a given actor. How many messages does a given actor have in the mailbox waiting to be processed? And for this, we also have the waiting time in the mailbox. For how long a given message was in the mailbox of an actor. We also have the dispatcher. The dispatcher is what it makes to tick an actor. Interesting thing that we could monitor about a dispatcher is, for example, the pool size, how many threads a given dispatcher has, the active thread, so how many threads starting to process a given action and still have not finished. Process start could be how many tasks a given thread have processed during a period of time. And finally, there is another thing that come on for Akka monitor out of the box, which is the router. The router is kind of a special actor that what it does is it can take a string of messages and dispatch or distribute across many routines or workers. So you can think like in a dispatcher. What it's taking is consuming many messages and then decide which worker can process this given job. There are many algorithms that can be applied to the router. Could be round robin, or could be something more clever. We check which of these workers have less tasks pending in their mailbox, and then based on that make a decision. So things that we could or would be very interesting to monitor is the routing time, how long it took the router to decide which worker is going to process a given task, for how long a given task was in the mailbox of the router. But wait a second, this is not in the router. This is a combination of all the workers, because the router, as I say, is a special actor. In fact, it doesn't have a mailbox. Once that you send a message to the router, it's not included in the router mailbox. It'll redirect into one of the workers automatically. One more time, processing time of the error that happened while they were processing. So let's go into the demo time. Our application have 4 different endpoints, very simple. The one that we're gonna hit is blocking endpoints. So behind this endpoint, what we have is just a single actor which, again, don't take it as a reference because it's doing something very wrong. It's calling thread.sleep during 3 seconds. Therefore, once that we make this call, we will not have an answer after 3 seconds. Here we are. There is something interesting here because we have a timeout of 5 seconds in our router, which is handling this request. What does it mean? It means that if the actor doesn't reply within these 5 seconds, the request is going to be rejected. How this affect us? Well, quite simple. If we now make 2 requests at the same time, one of them should fail because all these requests has been enqueued to the same actor. Here we have the first one. Therefore, the actor didn't manage to reply in time. Another endpoint that we have is of course a non-blocking actor. This one is doing almost nothing. It just receive the request, process that, and then reply back to the router. You can see here that it managed to reply in time always. If we create many of them, it keeps replying in time, and we can keep saturating because it's a very light job what it does. And if you remember, we also saw the concept of router. So of course we have another endpoint, which is a router which has 3 blocking actors behind the hood. Therefore, if we make a request, bang, fantastic. This is not the endpoint. Let me check it. The port, you're right. It will manage to reply to the request, and if we do 3 requests, knowing that there is a blocking router behind the hood, it should fail, but because it's under a router which have 3 of them in parallel working at the same time, all of them satisfies. If we create another one of them should fail because we only have 3 actors replying these routers. And here we have the first one. So why I'm doing all these things? To generate some noise in our application, and behind the hood, Camon has been collecting all these metrics. So let's see if we can understand what I've been sharing with you. Now we move into Camon dashboard. And here we have 3 different sections. The first one is for the actor metrics, the second one is for the routers, and the third one is for the trace, which we still have not seen, but we will see in a second. So let me zoom a little bit here. And you can see we have, can you see that? Yes. We have 2 different actors. The first one is the blocking actor, which is in green, and then the second one, which is the no blocking actor, which is in yellow. If you remember, we first did a request to the blocking actor, and this gets reflected here. And then after that, we did 2 requests, and it's also reflected here. But maybe some of you are asking, wait a second, Danny, we did 2 requests, but we saw that one of them failed. Why is this dashboard reflecting that this actor processed 2 messages rather than 1? In fact, you are right, the request failed, but the actor itself processed 2 messages. So if we want to see what are the number of requests that satisfy and what are the number of requests that fail, we need to go into a different level. We need to start using the concept of trace that we will see later. Then we're going to move into mailbox size per actor, which again, this is not a stacked number. This is not letting you know how many messages a given actor has during a given period of time. This is an average, and it's calculated. You can see here we have decimal. It's impossible to have 0.1 message in the queue. You have 1 or you don't have anything. But Camon is very clever, and rather than give you the exact number, what it does is calculate what was the minimum number of messages that we have during the period of time, what was the exact number, and what was the maximum, and then it calculates the average. A mailbox is nothing more than a queue, and based on the nature of actor, that the communication is always done through message, it's pointless to know what are the number of messages that an actor has in the queue in a specific period of time. It's better to know how it flows, how it fluctuates, how it goes up and down. We want to have some kind of threshold, and this will let us know if our actor is coping with all these messages. Time in the mailbox, we have here that for the second iteration that we did here, when we sent 2 messages to the blocking actor, one of the messages was waiting in the queue for 1.5 seconds. And then we have the processing time. Of course, for the blocking actor, as I mentioned, it takes a call thread.sleep during 3 seconds. This is why it gets reflected here. And for the no blocking, it's almost nothing. Then we move into the router. This is the last request that I did it. And this is interesting. If you remember in the configuration, I was not filtering the router, and this is why we have here a router which is called IO-TCP, and another one which is called IO-UDP, and then our router, the blocking router. So in order to remove this element from the dashboard, you need to add into the filter. I just leave it there to let you know that Akka by default, it creates its own actors in its own router, and if you want to have a clean dashboard, you need to filter them. In fact, these two actors that we have here are the ones that are in charge to accept the HTTP request that we did from the console, and this is why you see here the metrics. So if we just concentrate on our router, we can see here something similar to what we saw in the mailbox of the actor, the number of messages processed per router, the routing time, how long it took the router to decide which worker is going to process the message, the time in the mailbox per router. Again, this is a combination of the metrics of all the workers of a specific router, not just the router. And finally, the processing time per router. So once that we covered that, I just need to talk a little bit about the last concept, which are trace and segment. If you remember, this graph is very similar to the previous slide that we used at the beginning, where we were explaining what are the modern systems. We have the concept of a request or for a transaction. Then the transaction was composed by a group of subtasks. And the trace and the segment match them very well. The trace tells you the history of a given transaction, and the segment is by what a given trace is composed. So we use that to trace and monitor business metrics in our application. In the demo that we have seen, we are using that to monitor every single request that we are doing. So for the the request that we did for the not blocking, the blocking, and the router blocker, we have a specific trace. And this can be appreciated here. We have the get blocking trace, the get blocking router trace, and the get not blocking trace. Similar to what we have seen in the router and in the actor, we can check what are the number of times that we have called this trace, the time that it took to process the trace, and then the relative time per trace. In our example, we have not created. In our example, we have created segment. So here, it should be split across all the segments of a given trace. The problem is that this default dashboard doesn't go into the detail of the segment, but I can show you in the code how to do that. So as mentioned before, how can we trace a given route defined in Akka HTTP? The first thing that you need to do is just extend common trace directive. And then here you have the sample that we have used. We are going to make a get request to the path non-blocking. And then this, unfortunately, we have to do it explicitly. We have to give a name to the trace. In fact, it's not unfortunately. It's something that is a must, because you have to give to the trace a meaningful name. Maybe you can think, okay, why don't you use the name of the path? Yeah, you can do that, and it's very easy. You can create a directive and take the name from the directive, but Common cannot do that out of the box. For this example, I just brought it here explicitly to let you know how it works. We also have another trace for the get blocking, another trace for the get blocking router. If we go into the detail of our blocking actor, you can see here that we have on our onReceive method, which is the one that handles all the message that this actor is going to process. The type of message that this actor is expecting is a blocking task, nothing more than an object with the time that we want to block, which specifies the time that we want to block. And as you can see here, from this actor, we can get a reference to the current trace context and create a new segment. This is adding another dimension of to our metrics, and it's automatically propagated across all the actors through Common. So in every single actor context, you will always have access to the trace that it belongs. You also can create new trace, or finalize the trace, or create new segments. So how all this thing is done? Essentially, these are the recording instruments that Camon offer, which we can reuse for us. They have histogram, they have counters, min-max counters, and gauge. All this is reused by Camon by itself to inspect, to monitor our Akka system. But we just covered just a little bit of what Camon can offer. There are many, many things. So Camon also supports Scala futures. It can propagate the trace across different futures. They also support annotation, which for a Scala developer is not so good, but for Java, yes. It can report all this metric in our logs. We don't need to have all this stack that I showed to you. You can print everything into the logs. Another interesting thing is the remote system trace content propagation. What does it mean? So with Akka, it's very easy to develop distributed application. You can have a cluster of actors distributed across many servers. It would be very interesting that if in a server A we receive a request and we instantiate a trace, this trace is also, and for some reason this actor have to speak with another actor that lives in a different machine, it would be fantastic if Camon propagate the trace content to the other actor. Well, this is something that this guy achieved recently, and now it works with Akka remoting and Akka clustering, but not only with that, it also works with Akka HTTP. So if we have two applications, two microservices that exchange message through HTTP requests, in the HTTP request, Camon will inject by default a header, the xtrace token, and then it will be able to trace what is the full journey of a given transaction across all your microservices. This is done. Thank you, everybody.